Now, when trying to understand gravity better, we have to first go back to our early theories again and see that they all had one thing in common. Basically, at this point in time, even during the time of Kepler, it was always observed that forces required one thing to exist, and that is contact. And if you notice, in all of these, there is some sort of contact being made, either by invisible gears, invisible domes, the invisible hand of a deity or some other spiritual type influence. And nothing here is about lack of contact. And this kind of makes sense if you think about where people are in their time right now. The only forces they've experienced are what we call contact forces. These are forces like friction, tension, buoyancy. You need to be rubbing against two surfaces to create friction. There must be contact there. If I'm going to pick something up, I have to physically touch it. For me to feel tension in a rope, that rope needs to be touching me on one end and needs to be attached to something that's going to pull the rope on the other. I cannot experience a buoyancy force unless I am submerged in a fluid and that fluid is actually touching me. So the concept of planets just moving around with no physical contact seems really weird at the time. However, not all forces are contact forces. There is a small group of forces known as field forces. These are things such as magnetic fields, gravitational fields. We have nuclear fields as well as electric fields. Fields are often considered to be basically a type of energy that is emitted from an object, and when one field interacts with the field from another object, they create a force. These fields have been found for anything dealing with charges, the nucleus of an atom, as well as magnets. However, we have yet to find it for gravity. It is believed that perhaps gravitational fields is more a warping of time and space. However, even if that is the case, the concept of a gravitational field proves to be very useful and mathematically valid at this time. So our big takeaway at this time is that there's a group of forces known as field forces. These forces do not require contact of any type, but what they do require is two different fields. The force is created when two or more fields overlap and interact with each other. One single field can never make a force. It takes two fields to make a force. The fields must be of the same type, have to be both gravitational, both magnetic. If you interact an electric field with a gravitational field, you don't get an interaction because they are just the wrong type and they don't engage with each other and no force is being created there. A field will often be defined as the amount of force exerting on an object divided by that property of the object that creates the field. For gravity, it is mass. So a gravitational field that an object is embedded in, not creating, but embedded in, is equal to the force of gravity on an object divided by the mass of the object. So here I have the Earth, and I can see these arrows pointing toward the Earth. That represents the gravitational field. The symbol that we use is lowercase g. And if I wanted to find the gravitational field of the Earth, what I would simply do is I would have to place an object inside that field. This would be my object. And it would experience a force of gravity. So if I take this force of gravity and divide by the mass of this object feeling that force of gravity, I get to see the gravitational field made by the planet. Please notice at no point am I actually looking at the planet to find the gravitational field. I'm actually looking at the effects the planet has on something else to find that gravitational field that the planet has. Since this is force per mass, The unit is often known as a Newton per kilogram. Often when dealing with gravitational field problems, people become very confused because we have the titles M1, M2, and people often get confused on which mass am I looking at, which mass should cancel out. So to fix that problem, I personally have used new titles or labels. Instead of M1 and M2, I just label something as source and object. The thing I am looking at in terms of how is its motion being affected, the thing that is accelerating, that is always the object. The other thing that's causing the acceleration, the thing that's causing the orbit, that's always the source. This is completely and totally arbitrary from a particular point of view, but this helps me with my labeling. So I can now say that the gravitational field from a source acting on an object is actually equal to the gravitational force on that object divided by the mass of that object. Please notice this now prevents me from trying to consider or worrying about the mass of the source at all. And that's actually one of the easiest ways we can confuse people, because we can give you the force of gravity on an object, that mass of the object, ask you for the gravitational field, and people go, I don't know the mass of the planet, how can I solve for this? Or even worse, we give you the force of gravity on an object, and we give you both the mass of the planet and the mass of the object, and people pick the wrong mass to use in their calculations because they don't understand the relationship. They've never identified which mass is the source of the field and which is the object experiencing that field. And this force over mass is all about the experiencing the field. Likewise, I should be able to find the gravitational field made by a source looking at just the mass of the source and perhaps the distance from that source. After all, the source is making the field. I should be able to look at the thing making the field to figure out how strong that field is. And I can. What I do is I look at the definition of gravitational field and I apply to the force of gravity the force equation for gravity, because that force is created because of the two masses involved. Once I plug that in, I can actually see that the mass of the object reduces from the equation, and I now have an equation for the gravitational field made by the source. So the truth is I really have two gravitational field equations based on two different points of view. If I'm focusing on what's making the field, so the gravitational field from the source, then that would be my constant, gravitational constant, times the mass of the source divided by the distance from the source squared. Please note, this is only about the source. I've never said anything else other than source for mass or distance for the field made by the source. However, if I'm interested in what is the field that an object is experiencing, what is the field that an object is in, then that would be the force of gravity on that object that is experiencing the force divided by the mass of that object. Please notice it's a very different perspective. These are actually very easy to work with once you understand if you're looking at an object perspective or a source perspective.